Okay, this was in a post today. This is Roger, by the way, Mudfossil University. This was in a post today in Science. There's a huge audience of 300,000, more than that, people. And it says physicists are one step closer to cooling down antimatter. Now, let's look into what antimatter is, because I think we have photographs of it. Now, they're showing these little things, and they crash big particles into other big particles head on, and then they look to see what comes out. We accelerate light, so we're working with the little particles, 1,800 times smaller, but we have the physical evidence to show. And I'll show you that right this instant. All right, let's just start. I'm going to show you what my claim is that all of these fields, these are polarized magnetic fields. They surround an electron which is coming through this venturi, which accelerated it, turned it into extremely high energy particle, which came out as plasma. When that particle collided with all the particles that are in space, which every single thing there is coated with electrons. There's nothing that isn't coated with electrons. Every single thing there is. All in the air is 100% coated with electrons, every molecule. So every particle of light, which is a polarized electron, that's my statement. They're not waves of nothing. They are electrons. They have a mass. They have a spin, and they are a particle. When they come through the venturi, they become mechanically crushed into each other's regions, and they become explosive when they come out of there, because they don't want to be touching each other. When they come out of here, they zip out of here like a zillion miles an hour. They are accelerated. They crash into the actual air that has nothing more than a pile of electrons. They create shock waves, and then as the spinning particle, which is this little light particle, spins through air in this little tiny spot in the center, all the electrons that surround it become polarized and create the field. That's what a magnetic field is. It's polarized, what they would call ether. There's a ton of free electrons hanging on to molecules that are in the air, just floating around with them statically attached. They're free to do these kind of things. And they're free to collect on you and jump from you to the earth, which is the positive source that wants them. So my statement is that these are electrons coming out of here. They create fields. This one here is what they would consider antimatter. It's from their own statements. It came through the accelerator as light that were all issued from the same source as light. It came out of here as light. These have a negative magnetic field that surrounds them. This has no magnetic field. None. And it is extremely agitated. It's extremely energetic. That white is not something that these present. These present polarity as they spin. This is an anti-spin, and that creates no magnetic field. But the same particle from the same source, it's identical, spinning backwards, no magnetic field. Now I'm going to show you how we got to this, and then I'm going to show you what this ended up doing when it hit one of these. This is simply light from a pulsed red laser. The particle is only just here. There's only a few particles in here. It's a little tiny stream. I'll show you that in a minute. And you see all these other glowy little particles. They are being excited from being crushed by these particles into their regions. They own regions around themselves, like a tiny little dot inside of a beach ball. And they want that beach ball. Somebody bashes into that beach ball, they're both going to glow. What we did here is we shot that red laser through a venturi, two metal pins here. This was done 3-4 years ago by Rod Warren and I. We were doing experiments of light, and it ended up being accelerated through what is a standard Venturi. There's nothing special about this. There's two pins here. The light from the red laser comes down here. This right here, you can see, is the little tiny bead of the red laser. It's not this big wave coming down. That is concussion from the wave. It's just like a rocket going through, or breaking the sound barrier, and you get that big fluff around it, and that's what that is, because it's crashing through this barrier. And in this case, it's a negative particles crashing through negative particles, and you can see them down here. If you look down there carefully, you can see how glowy those little dots are. All right, they are being excited by this reverse wave. All right, because it's become so energetic in creating this plasma down here that it is sending back an enormous reverse wave. It's an electromagnetic field in reverse, because it's supposed to be coming this way. Well, it's reversing itself from this collision. And you can see the particles, and they are particles. They're not waves, they're particles. They're electrons. They collect in a crushing effect at the core, at the center of the Venturi, and they just force each other into each other's regions. They glow. They are now in a continuous plasma. Continuous. This is not a pulse plasma. This is just continuously feeding out of here in plasma. When it gets on the side, it just explodes away from each other because they're all negative. That's what creates the patterns here. Most of them are pushed from this way and this way into the center, and then they push and push and push and push and push, and they make the waves coming out. They look like waves. They are particle beams, strictly because that they're forcing each other, get away from me this way, and you get away this way, and they line up just like little troops running down the stream. Now, the ones on the outside are able to just swish off to the sides without being pushed back and forth in two directions. That's why they're fluffy, and the center ones are in stripes. That's what creates the interference patterns, not a wave. So, we've had light accelerated. Well, first of all, we had light from a laser. They're all the same light coming out. There's nothing special. One is specialer than the other. They all come together. They turn into a beam. Zzz, they crush. They're all in each other's regions. This is plasma. It comes out of here extremely excited. We think we can do this with protons. Protons are 1,800 times bigger than electrons. You would not even require the speed of the electrons to crush through a Venturi. If it was designed correctly, that would create protonic, continuous plasma. That's fusion. Now, we are in the midst of designing a resonance chamber. I have a fellow, Russ, over in England that's working on it right now. He's going to design it for electronic, as a demonstration, and we're going to see how it reacts. But this would have to be something very carefully designed to create a resonance chamber, creating plasma protonic reunions in the center of the plasma chamber, creating helium. Then you get 20% back, which is, you got a 2 and a 3, it ends up with a 4. The helium's a 4. So you end up with 1 left over, which in my world is 1,900 electrons. So for every molecule of helium from a fusion reaction, we can get 1,900 electrons to move something and drive whatever it is. Free electricity, basically. Because this is, you don't require anything. This is a passive crusher. This is a crusher. It's as simple as that. Crusher. It's mechanical. It doesn't require anything whatsoever. Now, Russ is going to make it so that we can, well, I don't know exactly how he's going to do it, but we were talking about making it, it's called a variable Venturi, a variable voltage Venturi. Because anytime you change the characteristic of the Venturi, you change the characteristic of the plasma, and the plasma is the voltage. So back to this one more time. Here's all the disks, and those disks are magnetic fields. Those fields are what they now would call Higgs fields, and they sit on a charged particle, which they call boson, and the boson comes out of Cherenkov radiation. It's from a neutron shower, and that's what we created, Cherenkov radiation, which is a little glowier, higher frequency than is what it's coming into. It's well, here, I'll show you a picture of it. All right, you got Cherenkov radiation, which means that from an electron shower produced by an electron neutrino. Now, they're calling it electron neutrino, it's a high-speed electron, really, is what it is. I don't know how they come up with electron neutrino, but it's an electron past the speed of light. It crashes into another medium, it creates an electron shower. That electron shower creates this diffused electron shower, those fields that present all over the place. And the reason this is happening is because this particle is crashing into other particles and sending them into this polarized array. All right, first of all, this is the spinning particle. It spins to the right, means drifts to the left. It's just accelerated from the Venturi, and it's in the plasma phase. It's not yet presented the Higgs field, and it started to collapse, and it's going to finish collapsing, and then the fields will be presented. Now, these are what they say antimatter is they're particles of matter and antimatter, identical. They're the same particle, only one has an opposite electric charge. So an electron has a negative charge, an antiparticle is a positron has a positive charge. Both have identical mass. That is what I'm showing. Now, I want to address one other thing. Oh, who are you to be talking about this? I get this all the time. And I don't like to say about myself, but this is what I did. I used to rebuild big equipment for General Electric, back when they had big motors and generators and huge things, thousands of pounds they weighed. Then I was in the Army. I serviced Nike Hercules missiles and electronic equipment related to that. Then I was in electronics and into a field engineer in troubleshooter for electronics, trying to figure out what kind of conditions cause problems in buildings and feedbacks and electromotor forces and static discharges and broadcast frequencies. And there was a million, billion, zillion things. I even had one girl that had a mat she used to stand on when she did her work, and it was a nylon carpet, and she would charge it up and she'd blow up a machine. I'd go out to figure out why these things were happening. She'd take her mat somewhere else and blow up another machine. There was no consistency to it. I finally discovered who the girl was. She had on leather shoes. And anyway, it goes on for, I had to come up with solutions for problems that occurred. So I became heavily involved in the electronics of everything, because that's what everything is, electronics. And then it was LEDs, and then it was this, and it was that, and then it was PN junctions, a positive negative junction. You shoot electricity into a bimetal, which means it's two metals layered one on top of the other, let's say, and they have different chemical characteristics. When you shoot electricity into them, they give off light, some of them. I said, well, why did that happen? So I go into, all of the deepness of it, all of the different angstrom units of how they bond and how the orbitals are arranged, and it's very deep, and I like that, but I don't go work for anything. I don't have any degree in this stuff. I did this in the real world, and I had to deal with it in the real world, and I had to go and find the real, honest-to-goodness solutions, not something I could postulate on. When I got done, that damn thing better work. And that's what happened. They worked every time. And eventually, we did have a hell of a time finding out the things that clamp electromotive discharges coming in from static and from line surges and from reverse grounding and so forth. That's why you see that big lump on the back of your monitor cords and things like that. That clamps down electromotive fields, which are those little round disks of polarized particles. They come flying down the line with static little extra discharges that come through there. They're not supposed to be there, and those things come with them. When they do, they slam into 5-volt chips, IC chips in there, and then they just scramble. So you have to suppress all these things. You do with capacitors and all kinds of things. Anyway, that's what I did. So I feel extremely confident to talk about this, and I will discuss this with anyone. So let's go on from there. But we're looking at antimatter as just an opposite charge to what the matter is. So it's what I'm showing. Okay, one last time before I show you what happened to this little bugger here, which I say according to their own statements, that would be antimatter. These present fields based on the fact that they are from a material, an electron, which came from a red laser, which was accelerated through a venturi, which came out of here in these little filaments, which crashed into the particles, which everything is surrounded by electrons in space. Every molecule, every air particle will become polarized, and that's what happened. That's the Higgs fields. Now, those decay almost immediately. It's because they're coming through so fast, and they crash, and then they go away. You don't see these just regularly. This is strictly the product of Cherenkov radiation, which is high energy compared to what it's slamming into. Now, so back to this particle. What did that particle do? What would you think that particle would do if it hit one of these particles? Well, this is not a particle, this is a field. This has no field. So, according to their own characteristics, they say this should destroy that. That's what I take from antimatter. Now, let's see what happens. All right, they had their picture, all the little fuzzy things spinning around in circles. Well, this is ours. Now, this is that white particle. You see the structure? It has some structure in there, but it's like an anti-structure apparently, because it still has a huge amount of energy. That's why it's so white and glowy. The others, the particle that the others actually have inside of these fields is so small that it's just not detectable in these shots. We do actually have pictures of them. As they come through the accelerator, they become visible for a very short time. I'll show you that at the very end. But that is that particle. Now, I'm seeing no field, and then all of a sudden it impacts with this field, and I'm seeing the creation of a similar pattern to this field. That's what I'm seeing. Now, I know you can see the same thing, unless for some reason the camera doesn't work well or your eyes don't work well. But it's what's happening. Boom, boom, boom. And then boom. Now, what is that? This white right here looks to me like the glowiness of the high energy particle. This is much more glowy and white than any of the rest. I mean, this is probably a reflection from this, because this is a very intense white. And then this disk coming out of here, this magnetic field, I don't know, it might be backwards. It might be spinning backwards again, bounced off of there. I don't know. These are the things I'd like to have somebody look at. But this is in the electronic range. But I do think we can do this with protons, because we've established continuous plasma. That's the key. They've only been able to do it for like a zillionth of a second, and they use all the electricity in the world. Boop, and it's done. Well, you're not going to get anywhere doing that. This is passive, and we can do it continuously. But it has to be done in a vacuum chamber, and it has to have a proton gas source, which shoots them up and speeds them up to very short distance. You don't have to, even like the size of a room you could do this in, because they're 1,800 times heavier than electrons. We're doing electrons. So in my mind, you're going to have at least 1,000 times more impact because they're bigger. Now, they still have the same charge. So that's the thing that I don't think is going to be a problem, though, because they're going to crush in easier because they have the same charge, one charge. Huge region, only a one charge. That means they should force into a plasma easier than the electrons. So that's my point. Okay, I've been talking about fusion and hoping that we can get to that. I see no reason. I spoke about what I thought protons would do coming through here. Now, this would be like a resonance chamber collector. It would go right after where they became plasma, and you'd create some form of a waveguide to bring them back in and collect them in some little cylindrical resonance chamber that they could vibrate off of the surfaces in there and combine in the center somehow. I mean, there's a lot of ifs and a lot of buts and a lot of this and that, but we've created the plasma. The plasma is the key. Now, once you get it in here, I'm saying you could draw off the helium. Of course, this has to be in a vacuum chamber, obviously. And then you could draw off the electrons as the excess electrons. And you're going to, once these protons, because there won't be electrons, there'll be protons, once they leave their state of H2, hydrogen with one neutron, and hydrogen with two neutrons, and I'm saying they're not really neutrons, they are extra electrons. That's what that is there. They're extra electrons. And what happens is they crush into each other's regions, then they spit out all those extra electrons. They didn't want them anyway. They were there just by accident. They're decayable electrons. They don't want to be there. They want to be in this very basic hydrogen state. So once they come out of here, they say, well, I want to be just normal. I want to get as stable as I can get. Well, helium is a noble gas, H2. I mean, He2. You know, it's got two electrons in the lower orbit, which makes it complete. That's it. It's noble. It can't do anything. It's as stable as it gets. So it turns into helium. And what happens with the other bunch of electrons that were stuck to the first protons? They say, well, we don't need you anymore. So they say, well, we can use you. I'll take you out here, and we'll go somewhere else, do work. That's fusion. That's what I was hoping to do. Now, I wish somebody would get a hold of us. You know, we do have some idea of what's going on here. I have a bunch of people working on this now. But nobody really paying attention, so we're not really getting anywhere. And we desperately need to do something to help the Earth. And fusion is the way. If this could help, it would just be absolutely amazing, because it's a static, it's a no-brainer. I don't have to have huge magnetic things to hold these things together and force them into each other's regions, because all you're doing is using one hand to slap the other hand. It's just wrong. It creates nothing. It uses a whole bunch of work to end up using the same thing to create the same thing. We're creating this by using the forces of nature. All right? Get a hold of me. Roger at Mudfossil University, please. All right? And subscribe and ring the bell and talk to other people in your field, please. This really needs to be done, and I'm willing to work with anybody, but I haven't found anybody willing to work with me. All right? Roger, over and out. All right, you just saw all the pictures I showed, and I showed Higgs fields with boson particles. I'm absolutely certain that's what they are. If they can say they're not, I'd like to know what they call them. This is right from today. This is August 30th, 2018, 9:30 this morning. I was just getting ready to post this video, and a friend sends this. This is why I get so much information. That I have 37,000 students that send me questions, and I dig into them. I don't just dump them off and say, oh, you're stupid, just read page 17. And this, she sent this morning, Margaret, and it says that they discovered the decay of the Higgs fields, and I'm showing them right now. So I don't know what they're doing, but I know they're using heavy particles. I'm using electrons. Different situation, totally different methods. But mine is very static, very simple, completely mechanical, no special requirements here that I can tell. But we need somebody that can accelerate protonic gases in a vacuum into a venturi, into a resonance chamber with an electrode to draw off any excess electrons, and a way to discharge the helium, and then it should just run. Alright, I told you we have some shots of the actual particles. That's coming out of the accelerator, high speed, all blurry plasma. Then they step down a little bit, and then right away they turn, the red ones, because they're so weak, they turn into those little particles. Then they change. This is like, I believe, where the boson fields, the Higgs fields is presented. I really can't say for sure, but this is what Rodney captured, and he captured a bunch of this stuff. I'll show you some more. And Fabian, another one of the guys that's working on it now. Rodney, of course, did the original research, and I did it with him. I took a lot of pictures too, and took a lot of things, but Rodney's work is unsurpassed. Now, because he just put so much effort into it. Now, I'm going to show you how it affected the green and And now we're trying to get started with the blue, and but the green is much more powerful than the red. But the same particles show up. So here we go with the green. All right, you see where the green is? Way out here, and they get these fuzzy trails. And I was looking at that this was from Rodney, and I thought, wow, why is there such a difference between that and the red? And of course it's the frequency. Hold on a second. But anyway, that is the particle. I mean, I think they're particles. So I'll show you some other ones that Fabian just did recently, who's doing some pretty good work here too. Now, I'm seeing something that looks like it's flip-flopping or has some kind of a toroidal polarity. And I don't know if it bangs into something, maybe it bumps and creates some kind of pulses out the tops. I don't know. I was thinking it had something to do with capacitive and inductive reactance, where the neck of a torus is a restriction. It's an inductor. It crushes fields. Is what I've been talking about, is field crushing. And then you have the tank surrounding it, which has a capacitance, a large capacity to hold whatever it is that it's holding. This is where you get down to this particle. It is what it is. I don't know what to say. But if I do know that if you crush an incoming field, it can literally force it backwards up to 10 times how quick it comes in. So if they were coming in here and then pushing back harder than they were coming in, they might fill up and then come back and fill up and come back. I don't know. That was the only thing I could come up with. It's inductive and capacitive reactance. Just a guess. Now, Fabian did a little work here where he put the red and entangled it with the green. Look where the green comes, way out here. See, the red is just instantly crashes into the new media, a medium that it's smashing into after the accelerator. The greens carry on, and then they do that trail which I was talking about before, and then they present the same particles. He's not getting the quality that Rod was getting of the but you can see they're in there, and he's got some other shots. I'll show you another shot. By the way, Fabian also had an experiment on the space shuttle that related to water and bubbles in water, and now he wants to come on board with us and take a look at light, and we like to have people that like to experiment. So everybody else is perfectly welcome, and it's a very simple process, very simple. And I think Rodney's coming back on board. He walked away from this for a while and went into other things, and I'm hoping he's coming back. So we're presenting what we can present, and I'd love to see this end up with fusion and try to help what's going on with sucking all the fluids out of the earth. I mean, even if it's carbon dioxide is not an issue, sucking everything out of this earth is. Let me tell you that right now. It is collapsing. All right, this was Fabian again, strictly the green. Look at how far they come out before they crash. And here are the particles. Now, they only hang in here for a couple of waves. I've seen only 2 waves, two magnetic field pulses. I mean, look, this is just amazing, the unbelievable details. And these are not from any special photography equipment. These are from cell phones with, I don't know, 10 megapixel cameras. And then they work on them to look in deep, and they're doing videos and checking things. I do a lot of other stuff, so I got people to do this much better than I could do it. So it is what it is. It's time to look into it, because if this could create fusion, I mean, just think of an enormous boon to society, to humanity. And if it's something simple, and it looks like it is simple. Now, if they gear up for this, I'm sure they could figure out a way of creating these gases that would be in little cylinders, like you buy a CO2 cartridge and you plug it in and you got some fusion. I mean, I'm telling you, I don't see it as a major deal. I really, honestly don't. It needs to be looked at. It really, really does.